Hello everyone. In our previous lecture, we discussed the basic concepts of Python operators and expressions. We understood that operators are symbols that perform operations. Operands are the values on which operators work. Expressions are combinations of operators and operands that produce results. We also connected these concepts with civil engineering examples such as construction materials, tools, calculations, and measurements. Now, in this lecture, we are going to study Python operators in detail. First, we will understand the different types of operators available in Python. Then, we will begin with the first and most important category, that is arithmetic operators. Now, before studying arithmetic operators in detail, first we must understand the overall classification of Python operators. Because in Python, operators are not limited only to addition, subtraction, multiplication, and division. Python also provides different categories of operators, and each category is designed for performing a specific type of task. Just like in civil engineering, different tools are used for different works. For example, a concrete mixer is used for mixing concrete, a total station is used for surveying work. Similarly, in Python programming, different operators are used for different types of operations. You may have a question in your mind that why does Python provide different types of operators? Well, let us understand this in a very simple way. Suppose in a real life, different task requires different tools. For example, in civil engineering, to measure length, we use a measuring tape. To check levels, we use a leveling instrument. To mix concrete, we use a mixer machine. And to cut materials, we can use different cutting tools. Can one single tool perform all these tasks? Obviously, no. Similarly, in programming also, different operations require different types of operators. Suppose we want to perform calculations like addition or subtraction, we use arithmetic operators. If we want to compare two values, we use relational operators. If we want to combine multiple conditions, we use logical operators. Likewise, other operators can be used based on the calculation requirement. So, each operator category is designed for a specific purpose. This functionality in Python makes programming more organized, more readable, and easier to understand. That is why Python provides different categories of operators. Now let us study arithmetic operators in detail. So, arithmetic operators are generally used to perform mathematical calculations in Python. Just like we perform calculation using a calculator, Python also provides special symbols called operators to perform all these mathematical calculations automatically. These operators are extremely important in engineering because engineering problems continuously involve mathematical operations. As a civil engineer, almost every calculation we perform involves arithmetic operations. For example, during engineering work, we perform quantity estimation, area calculation, load calculation, traffic analysis, concrete mix design, survey calculations, cost estimation. So in Python, arithmetic operators help us to automate these engineering calculations. Now let us see the major arithmetic operators available in Python. Now let us understand our first arithmetic operator in Python, that is addition operator. When we hear the word addition, we immediately think about adding numbers together. Just like we add the number of cement bags, bricks, length of roads, or quantity of concrete in civil engineering, Python can also add values for us. So instead of calculating everything manually, we can ask Python to perform the addition. Now this addition operator is represented by the plus symbol. This is exactly the same symbol that we have been using since our school days. So there is nothing new about this symbol. So the purpose of this operator is very simple. It is used to add two or more values together. For example, 10 plus 20, 100 plus 50, 25 plus 35 plus 40. All these calculations use the addition operator. Now, these values 10, 20, 100, which are participating in an operation, are called operands. So whenever we use an operator, the values on which the operator works are called operands. For example, if we write 10 plus 20, here 10 is an operand, 20 is another operand. So there are two operands. Now let us understand exactly what happens. We have the first operand 10, we have the second operand 20, and between them we have the addition operator. Python simply adds these two operands, that is 10 plus 20 equal to 30. So the addition operator performs only one job, that is, it combines the values of the operands by adding them together. So remember one simple rule: the plus sign tells Python to add the values of the operands. Now that we know what the addition operator does, let us see how we actually use it in Python. In programming, we follow a particular writing format. This format is called the syntax. For the addition operator, the general syntax is result equal operand 1 plus operand 2. Here, operand 1 means the first value, operand 2 means the second value, and the result stores the answer. We can also write it in another way: variable equals value 1 plus value 2. The variable name can be anything meaningful. For example, total, sum, marks, area, volume. So keep it in mind that Python does not force us to use any particular variable name. Now let us understand this sample program line by line. A equal to 10, that means Python creates a variable called a and stores the value 10 in it. Now b equal to 20, that means Python creates another variable called b and stores the value 20 in it. In step 3, c equal a plus b, here Python does not add the letters a and b. It first checks what values are stored inside a and b. Here A contains 10, B contains 20. So Python performs 10 plus 20, so the answer is 30. And it stores the value 30 inside another variable, that is C. Now here in this line, print C, this is one of the most commonly used statement in Python. It tells Python to display the value stored in the variable C on the screen. Here the variable C contains the value 30. So the print function displays the value 30. Notice one important thing, Python always works with the value stored inside the variable, not with the variable name itself. Now let us understand this operator using a civil engineering example. Suppose a construction project is going on. On day 1, 100 cement bags were used. On day 2, 50 cement bags were used. Our objective is simple. We want to calculate the total number of cement bags used over these 2 days. Whenever we solve a real life problem using Python, the first step is always to identify the given data. Once we clearly identify the available information, we can represent it in our Python program. In this example, the given data is day 1 equals 100 cement bags, day 2 equals 50 cement bags. So instead of calculating manually, let us ask Python to do it for us. We will store these values in variables and use the appropriate operator to calculate the total number of cement bags used. Our first step is to store the number of cement bags used on day 1. So we create a variable named day_1 and assign it the value 100. Notice that the variable name is meaningful. Just by looking at it, we can easily understand that it represents the number of cement bags used on the first day. Next, we store the number of cement bags used on day 2. For this, we create another variable day_2 and assign it the value 50. Now, our program has stored the data for both days separately in 2 variables, that is day_1 and day_2. Our next task is to calculate the total number of cement bags used. Since the result also needs to be stored somewhere, we create another variable. Let us name that variable total_bags because it clearly describes the information it will contain. Now comes to the most important part. Let us understand how Python executes this statement total_bags equals day_1 plus day_2. At first, Python looks inside the variable day_1. It finds the value 100. Next, Python looks inside the variable day_2 and finds the value 50. Then Python applies the addition operator to these 2 values. So it performs the calculation. 100 plus 50 equals 150. Finally, Python stores the result 150 inside the variable total_bags. At this point, the variable total underscore base contains the value 150. So till now we have completed our calculation, but the result is still stored inside the variable total underscore base. To display this result on the screen, we use the print function. The statement print total underscore base tells Python to display the value stored in the variable total underscore base. Since total underscore base contains 150, so Python displays 150 on the screen. Let us quickly summarize what we have studied about the addition operator. The addition operator is represented by the plus symbol. It is used to add two or more values. The values on which the operator performs the addition are called operands. In Python, we typically store these values in variables, use the plus operator to add them, store the result in another variable, and finally display the result using the print function. With this, we now have a clear understanding of how Python performs addition. So let us move on and understand how the subtraction operator works in Python. Just like addition, subtraction is something we use regularly in civil engineering. For example, we subtract the number of cement bags used from the total stock. We subtract the completed road length from the total project length. We subtract expenses from the total budget. So whenever we need to find what remains after removing some quantity, we use subtraction. The subtraction operator is represented by minus symbol. This is the same minus sign that we have been using in our mathematics. So again, there is nothing new about this symbol. So the purpose of the subtraction operator is very simple. It is used to subtract one value from another. For example, 20 minus 8, 100 minus 30, 500 minus 135. In each case, we are removing one quantity from another quantity. Just like the addition operator, the values involved in the subtraction are also called operands. So if we write 20 minus 8, then 20 is an operand and 8 is another operand. The operator works on these operands to produce the answer. Now let us understand what actually happens when Python performs subtraction. Here we have the first operand, which is 20. Next we have second operand, which is 8. And between these two operands we have the minus sign, also known as the subtraction operator. This operator tells Python what operation needs to be performed on these two values. Now, when Python executes the subtraction operation, it subtracts 8 from 20. So the calculation becomes 20 minus 8 equals 12. The result obtained after performing the subtraction is 12. Now remember this simple rule. The subtraction operator instructs Python to subtract the value of the second operand from the value of the first operand. Now let us see how we perform subtraction in Python. Just like the addition operator, the subtraction operator is also follows a fixed syntax. Let us understand its general syntax, that is, result equal operand 1 minus operand 2. Let us understand each part of this syntax. Operand 1 represents the first value, operand 2 represents the second value. The minus symbol is the subtraction operator that subtracts the second operand from the first operand. Finally, the variable result stores the difference obtained after the subtraction. We can also write the same syntax as variable equal value 1 minus value 2. Here, value 1 and value 2 represent the two values that we want to subtract. The variable on the left hand side stores the result of the subtraction. Notice that we have used the word variable in the syntax. This does not mean that the variable must literally be named variable. We can choose any meaningful name that clearly describes what is being stored. For example, if the subtraction gives the number of cement bags remaining after construction work, we can use a variable name like cement underscore left or remaining underscore cement. Always try to choose meaningful variable names. A meaningful variable name makes your program easier to read, understand, and maintain. Now let us understand how Python executes this program one step at a time. As Python reads each line, it performs the corresponding operation and stores the data in memory. In this first statement, a equals 20, here Python creates a variable name a. Then it stores the value 20 inside that variable a. At this stage, the memory contains only one variable a with the value 20. Now the second statement, b equals 8. Here, Python now creates another variable name b. It stores the value 8 inside the variable b. Now the memory contains two variables, that is a which stores 20 and b which stores 8. Now c equals a minus b. In this statement, at first Python looks inside the variable a and it finds the value 20. In the next step, Python looks inside the variable b and finds the value 8. Then Python applies the subtraction operator, so it performs the calculation. 20 minus 8 equals 12. Finally, Python stores the result 12 inside another new variable c. At this stage, the memory contains three variables A, B, and C. The variable C now stores the value 12. Now coming to this print statement, that is print C. Here the print function tells Python to display the value stored inside the variable C. So Python looks inside C, finds the value 12 and displays it on the output screen. So now observe one very important point. Python is not subtracting the variable names A and B. Instead, it retrieves the values stored inside these variables, that is 20 and 8, and performs the subtraction on those values. So remember one thing, variables simply store data. Python always performs operation on the values stored inside those variables. So now that we understand the syntax and execution of the subtraction operator, let's apply it to the real life civil engineering problem. Imagine that a construction project is in progress. On day 1, the construction site receives 100 cement bags. During the construction work on day 2, the workers use 30 cement bags. Our objective is to determine the number of cement bags remaining after day 2. In this example, the given data is day 1 100 cement bag received, day 2 30 cement bag used. Now let us write a Python program to calculate the remaining cement bags. At first, we store the number of cement bags received on day 1. So we create a meaningful variable name, that is day_1, and assign it with the value 100. Next, we store the number of cement bags used on day 2. So we create another meaningful variable name day_2 and assign it with a value 30. Again, we need another variable to store our final answer. Since this variable will store the number of cement bags remaining after use, let's choose the meaningful name remaining_bags. So the statement remaining_bags equal to day_1 minus day_2. Now let us see how Python executes this statement. At first, Python looks inside the variable day_1 and it finds the value 100. Next, it looks inside the variable day_2 and finds the value 30. Now Python performs the subtraction, that is 100 minus 30 equals 70. Finally, Python stores the result 70 inside the variable remaining_bags. Now the statement print remaining_bags. Here the print function tells Python to display the value stored in the variable remaining_bags. Since remaining_bags contain the value 70, Python displays 70. So finally, we understand that the subtraction operator is represented by the minus symbol and it is used to subtract one value from another. The values involved in subtraction are called operands. Python subtracts the values stored inside variables, not the variable names themselves. The result of subtraction can be stored in another variable and displayed using the print function. So far we have understood two arithmetic operators in Python: the addition operator, which combines values; the subtraction operator, which finds the remaining value after removing one quantity from another. In the next session, we will discuss all other arithmetic operators. So see you in the next session.